number three, this is actually one of my favorite problems in this problem set. So let's see the problem. Bookmark has the number one. He proceeds to generate a number by a preceding digit that is either double or half the previous. Of course, she only half if this is an even digit, and she's not allowed to double a digit if it results for in a two-digit number. Also, no two adjacent digits can be identical. He wants to repeat the process until he generates a 10-digit number. The probability bookmark's 10-digit number has an even digit sum is m over n, where m and n are relatively positive integers. So let's find m plus n. Um, so for this problem, we can see what let's fill the problem first. So we can start here. We have one. Right? Let's just have an example here on how it works. Right? We have one. You cannot divide it. You cannot half it because it's an odd number. You can two. If you go two, then you can let's say go four. You need to go eight. But you have to half the next one because 8 times 2 is 16. Right? Of course, which is not possible. Okay, that's a two-digit number. This will be back to 4. This will be, let's say, 2, 1, then back to 2, 4. Okay, numbers left. Let's say 4, 8. That would be 5. That would be 10 digits, correct? Okay. So this is an example of a possible 10-digit number that bookmark has, right? But seeing that we need the bookmark 10-digit number to be an even digit sum, this will simplify the problem that we need even number of ones, right? We are going we need even number or number or 10-digit numbers. With even number of the digit 1. All right? And when dealing with this problem, I think when you're, let's say, trying to fill the problem, you can actually see that this would be recursion or recursive, somewhat like that. So, and when I do, recursion, I usually do it in a tree diagram. For example, 1, over, 3, 4, ganyan. Just an example. That's not really the recursiveness. But when you're doing like a tree diagram, at least you try to define what the branches mean if you're going up or going down. Right? So let's define that here. One thing that we can define here is, let's say, if going up, let's say for number n, it's like a piecewise function actually. If you go up, like if the branch is going up, this will mean multiplied by you will twice the number. So, but if it's going down, this will go down the number. Okay? So using that, we can try to, let's say, create a tree to, let's see what are the possible 10-digit numbers later on. So create that tree right now. This might take a long time. Let's say start with 1. This is always the first digit. So let's draw 1. But there's also instances what there's only one line. For example, if you have, let's say, a number 1, you cannot divide it, right? That would be 1/2. So meaning it can only go straight or be multiplied by 2. Similarly, for 8, it can only be divisible by, it can only divide by 3. So you multiply it, it will go to a two-digit number. Oh, 4. Wow, that was wrong. Okay, so we can try to create it in a graph that can help us solve the problem. Okay, so starting with the first digit here, we start here. The second digit here will be 2. Going up, we have 4, then we have 1. Then, wait, might be new to I think this problem is really bashy, I guess, in some sense. So, 1, 2, 4, 1. You go up here 8. And what I like to do with this graph is try to combine it if there's common term or two branches. For example, 2 here. This one is 4. Then go down to 1. And this will have a branch. It will have this type of branch that we have here. Right? 4, 1, 2, 8. How many numbers is that? 1, 2, 3, 4, 8. Okay, 2 ones. Go down. 1, and 3, 4. Then last one, right? 8. And happy. Happy. So this is from not it again. This will be not the first digit. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. This will be the first digit, and this will be the 10th digit. Right? So we basically made a graph of this already. And first, we can try to find first the total number of where is it here? We can try to find the total number of possible bookmark and digit numbers. So we can do that in counting. We have 1 here, then 1. Uh, I call it red, but it not means the power. Okay, it means the number of ways. Right? We can go 1 here, go 1 here, go 1 here, goes 1 here, then go 2, then go 1. Why 2 here? Because we add 1 possible way and 1 possible way here. Okay, that's how it works. So here 3, 2, 5, 2. So notice how the numbers actually look like Fibonacci. I think some people will already see that. Then you check what the numbers are. 13, 8, then 1 here, 21. It will be 21 on the top, and then 34. So now we just have to count these totals, meaning the total will be 21 plus 34, which is 55. So, can I move this down? Or do you think that? I'll move it on the left side. That's the, oh, I'll move it down. So now, we will find now, uh, possible, right? Possible combination number. So, when I counted this might be, I think some people would efficient way. There's very, it's not an efficient way. Um, there are people who do this in an efficient way, but I would try to do how I solve this one. So we can start here that we can pick, of course, this would always be the first number. Right? We only focus on the digit 1, right? We need even number of digit 1. So we have two cases. You can either pick only 1 here, right? Because this is always guaranteed. The first digit, the digit 1, is guaranteed. So it's either you choose one of any of these, or you, one of any of these, or you choose 3 of them, right? You can choose these 3, or you can choose these 3 if it's possible, if it is possible. So I think we will go, I guess, case by case. Uh, and I think some people would also try to case. This was probably take a bit long, so we will count it. I will introduce you to the different colors, the columns. will continue. It must go one, one, it must go to the next number, right? So it goes down here. One, one. I think this is just counting now. So two here, four, four here. Did I count it right? Oh no, I counted wrong. Sorry. Oh, my bad. I thought one here, one here. Then two, two, and two here. Then four, then four and four. So count the sum of these ones. We have here eight. Yes. Okay. Then next case again. Yeah. Um. Then instead of choosing this one now, you can choose the other one here. So again, uh, put two again here. I think like um when once you try to bash it, it will actually feel it will not feel too long if you know how it works, like how the graph works. So I think once you like try to bash this already, this would be easy. This would be it won't be confusing if if this thing. Um and one here. I'll continue, okay? It might take a long time, but I feel like if I continue, it should take a lot of time. Or let's see. But eventually, I think this would try to find the possible cases for this problem, even with the probability of that thing will happen. I'll stop talking and continue to find the number of cases. Two here, two, oh, no, one. Four. Then I think I already did it in advance, like for others. If you I think if you try to check here, you check here, you, you can go like for example, you check now here as well. For this one, another one. You can go up here and down here, so you can actually go down. Then what about the two, 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 the four. Again, so this would be eight to four, then three. On my note, it says for the last case here, that would be four, one, one, two, two, four, two, two, four down here, four down here. Yeah, it will be four. So now, those are the cases if you pick one in between, right? Then for the other case, I will probably erase some of the numbers here already because it might be a bit no, but I think this would be like a bit confusing between these different types of colors and numbers. I will just erase some of them. When I will fix here for the other cases now. Okay, next one. This would be let's try three cases. Is it possible to get these numbers? Okay, we'll try this one. So we go one, no, one, go one, um, one, 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 one. Not mistaken, that's how you solve it. So that's two. Okay, I think that's right. So we go plus two. We have here two choices there. Then yeah. Then let's say for another case of numbers here. We can check this one maybe and see what happens here. We go one, 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 one. We go up here. Goes we go up here now. Goes up down here. So that's only one way, right? We go like this, but there's only one way. So I'm pretty sure there's one way there. Oh, wait. The graph seems to be missing. Then check other cases if there's possible. Like if we start now, if we skip the first bit, digit one here, then we will continue here. Then we will try to count in a different column. I'm very for that confusion here. One, 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 one down here, continue, continue here, one, one, there'll be one here, one way for that case. Then, oh, I don't know, did I miss something? So, let me check what that. Did I miss something? Down here. Hmm. Did I miss something? The answer is supposed to be 12. Yeah, there's supposed to be one more case. I'm missing it. Or I might have counted it wrongly already. I'll double check. Before it's mm, oh wait, okay. I think it's one case. Yeah, I did this one case. Here. Yeah, I did. I think I did. I saw on the screen. If I didn't start with this digit and I started with if I go let's say, and I started with this digit with the first one, then I skip this one. I skip the other one. This will be one. Put off here. Or did I do this already? I don't know if I did. Maybe. Okay. I feel like I'm trying to solve it right now as well. So I'm very sorry. It takes a long time. Oh yeah, I did miss one case. The other one. Yeah, I'm very sorry. It was this case. There's only one way. You can go one, here, you go down here. Then eventually you get only one case. So yeah. So basically, I think with this problem, you'll get you'll have to. I think there's a better way to bash it. And so the total here would be 55. So the probability would be 25 over 55 equals to 5 over 11. So yeah, that is the answer here. So 5 plus 11 is equal to 16.
Okay.